good afternoon and good evening, depending on the time you're watching this video. So welcome to LFX. If you are the first time you are coming in contact with our channel, so you are welcome. And if you are coming back again, as you are coming to, you are a returning viewer, you are welcome back. In today's video, we are going to start a new fresh series which I have already promised you before. We are going to be analyzing different topics. We're going to be analyzing different topics and in which Jamb questions, likely Jamb questions you are going to meet. So we are going to today's video we are going to be analyzing some questions in chemistry. So I'll tell you the topic, I will analyze and talk about that particular lesson. We'll bring one question on it. So I will tell you the topic it is, then we'll analyze the questions together and after we can choose the answer. So if you look at your screen now, you see a question that appeared. And the question says, the subatomic particles located in the nucleus of an atom are, it says subatomic particles located in the nucleus of an atom are. Now, and this particular topic is from atomic structure. And when we talk about atomic structure, according to Rutherford, we have this as the atomic structure. Then we have here we have inside here is the nucleus, and inside the nucleus we have the proton and the neutron. The proton, and we also have the neutron. Then we now have an electron here. Then here, this particular two things is called the nucleus. These things now that houses the proton and the neutron is called the nucleus. Now, for the combination of this particular proton and neutron is called the nucleon. So this is the major atomic structure of this is the atomic structure. So let's use this and answer the question again. They say the subatomic particles located in the nucleus of an atom are, they say A, neutron and proton, B, proton and electron, C, proton and ions, and D, neutron and electron. And I know you already know the answer. That the answer is what? Neutron and proton. The reason is that the proton and neutron is located inside the what? Nucleus. So that's about that. So in number 2 question in what you're going to see in the screen is under organic chemistry and is going to be nomenclature. So they say we should be about nomenclature of the structure. First of all, let me give you just few rules on how to name a compound before we now come to this particular. Remember also I saying this particular video is going to be a bit longer, but just have it in mind we are going to be analyzing videos and going to analyze some questions and etc. Now, we also have our own colleague, one of our favorite science teachers, that will also be taking over some of other sciences. Just make sure in these next few days, make sure you subscribe. Don't miss out. We are going to tear Jamb. Let's go back. So now let's come up. Now we have. Let's just give you small clues on how to name a compound. If you have an organic compound, first of all, what you're going to do in Jamb is that you have to first of all put it in a structural form first, so that it's easier for you. And the first rule you are going to have in mind is that you should have to identify the functional group. If you don't know how to identify the functional group, we already have the video in our channel. We are going to leave the video in our description and other things. Okay? The few rules on how to name a compound. First of all, we have let's assume we have these. Before we go back to this particular, remember we're analyzing, we have this. This CH2, CH2, and CH2. Remember, the first thing I said is that you have to have in mind that you know how to identify the functional group. Do you understand now? So we have a video on that. I made sure I explained that. I think it's just 10 minutes video just for functional group. So I explained that very well. So just try. So the first thing I'm going to do now is that if we bring this in the structures, we have this. This. You can can see that this first carbon is carrying 3 hydrogen. You can see as I break it. The second one is carrying this. The third one is carrying this. This one is carrying this. This one is carrying this. This one is carrying this 2. This last one is now carrying 3 hydrogens. You can see it. Now, if you look at this ones now, if you look at this particular one, you can see that this one is not carrying this one is carrying 3 and other things. So the next thing I'm going to now do is, for first thing to do is to identify the functional group. How will we know the functional group? Once you see a single bond like this is one bond. This means that this particular compound belongs to alkane. You understand? Now, but if you now see something like a double bond, once you have a double bond, that means 1 hydrogen is lost, as the 2 hydrogen is lost. And this particular bond, which was presumed to be carrying these hydrogens, will now turn to a what? A double bond. This is what I say. If you have double bond, that means 2 hydrogen is lost. And in this particular case, we now have double bond. So now for this particular case, the functional group is now what? This is now going to be what? Alkane, because of what? Carbon to carbon double bond. If we have 3 bonds, that means alkyne, that is ALKYNE. So let's assume now, okay, we have this one single, or we have hydrogen, we have hydrogen, they will now have OH here. Because of this particular OH here, this has already is a what? A functional group what? Here. So make sure you check out that video so you can know more about functional group. But this particular thing has already made this to be what we call alkanol. You get that now? Now, that's the first thing you are going to do. So for this particular compound, what you are going to do is that this is our an alkane. So just write ANE here. That's the first thing. That's cheat there. Now, ANE. Why are we writing ANE? Alkane. What's ends it? ANE. That ANE is just like their song name. Now again, now check how many carbon can you see here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 in organic compound, we call it what? Pent. This is now. So now add pent to this A, it's now become pentane. Pent to this A, it becomes what? Pentane. That's the first step to know when you are naming this. Now, what if you now have what we call a substituent group or an attachment group? What if you have it now? Let's assume now that when you are naming, you put something like chlorine here. You put 2 chlorine here. Where is it appear? In the third carbon. So let's look for it here. So, and the chlorine is just to put chlorine here. And also put another chlorine. Now, you now have to try as much as possible to represent this chlorine so that when you are naming it, people will know that there is a chlorine when you are naming it. And we have a rule that once you are dealing with a halogen as an listing, halogens are example fluorine, chlorine, bromine, and iodine. Even acetylene is also a what? Even though that one has not been proven, but those 4 I mentioned earlier is a what? A halogen. So when you are dealing with them, we change that particular INE at last to O. So something like fluorine, we change it to fluoro. Chlorine, we change it to chloro. Bromine, we change it to bromo. And iodine, we change it to what? Iodine. So thank you very much for following. So now the next thing I'm now going to do is just to identify where you see this. Which is the carbon you see this. The carbon number I saw this. The carbon number is as carbon number 3. If you count like this, 1, 2. In organic compound, you can count from anywhere you like. You can count from here. So you count 1, 2, 3. This is carbon number 3 that will solve this. You understand now? So if you come here now, you saw this as carbon number 3. Now let me ask you a question. What if this was solved, this one was in carbon number 2? And if you count from here, this will become carbon number 4. Which one will you pick? Let's see. Which one will you pick? You pick the one that is what? Lesser. Did you get that now? You pick the one that is lesser. So that's actually that if this one was here, that means you pick the one that is what? Lesser. It will not mean that this one that was in 2. That's why you are going to pick. You get that now? So now for this particular one, if you count from here it's equal, if you count from here it's equal. So that means if you want to name this now, let's identify where this thing is. We now have it in mind that this is, we now have, this is 2 chlorine. So have, when we have 2 in chemistry, we call it what? Di. Thank you. So have 3. The other one was also finding what? 3. 3 for this, 3 for this one. 3, 3. Dichloro. Pentane. That pentane we are putting it for. And that was for this. Now let's go back to this my question. Look at our question here. I think this resembles what we even want to be said. See, look at this. Okay. Now have this particular. Now, if you look at this particular question I'm showing on our screen, please, if you are enjoying this video, don't forget to click on that like button. Drop a positive comment in the comment. This is one of the things I keep on going. And if you feel that what you are doing is good, you can smash the subscribe button if you have not done that. Let's go back to our video. So if you see this now, we have, this is first thing we are going to do. Break down the compound so you can be able to know, as in, so that it will not confuse you. So now, first of all, first thing I taught you is that you have to count. You have to know, first of all, identify the functional group of this. And if you check, it's only one single bond we have. Because we have one single bond, where do you think this particular destiny is going to belong to? This is going to belong to what? Alkane family. So we write our A, N, E, which means their sole name. Thank you, you are following. Now, if we now have this, let's now count how many carbons we have here. 1, 2, we can count, let's start from here. We can count in 3 ways in this particular. We count 1, 2, 3. That's the first way we counted. 1, 2, 3, 4. Now, there's another thing you have to pay attention. When you are counting, if I'm counting like this, I can't go back and count again. Once you have counted towards the side, you have counted. So 1, 2, 3, 4. So the first one we counted, when we counted in the first one, we get 3. When we counted the second one, it was 4. Then when we now count 1, 2, 3, 4, like this again, we also get what? 4. Now, in A, B, C, which one do you think we are going to use? So this 4 is going to equal it as 1. So in these 3 and 4, which one do you think we are going to what? Use? According to your back, they say we should use the longest continuous chain. So the longest continuous chain, that's what we are going to use. So we are going to use what? 4. So if we count like this 1, 2, 3, 4, this is what we are going to use. And according to what is the carbon which is a 4 as member that has 4 carbons, that's what? Boots. So if we add boots to this, that becomes what? Butane. You understand that? It becomes what? Butane. The first step is done. So we can start to what? Be happy, bring one cold drink and chill. Let's go to the second step. The second step, what are we going to now do? Second step, I think you should identify a substituent group or the attachment. If you look at this now, what again that is not a hydrogen? Look at that to know it. What is not a hydrogen? What is not this hydrogen that is attached to this? Do you understand now? That is attached to this. Let's now check. This is not hydrogen attached to this carbon. This one, even though it's carrying hydrogen, we didn't count it when we are counting. We counted as 1, 2, 3, 4. Because we didn't count this when we are counting. This automatically becomes what? Attachments. Do you get that now? As we have counted this, the side that will not count is also the side we will refer as what? An attachment to what? Group or a substituent group. So this is what we are looking at now. These two things are attachment group. Now remember that I told you that when we are doing this is a what? A halogen, and we'll change the name from chlorine to chloro. Now what is this? This is just like a what? A alkane that lost 1 hydrogen. And when we say alkane that lost 1 hydrogen, what is it going to be called? It's going to be called an alkyne. And this is having 1 carbon because it's what? It's having 1 carbon. This is nice of being a methane, it becomes what? A methyl. So this is a methyl. Now, the next thing we're now going to do, the second step is what? Done. Second step, done. Let's go to the final step before choosing an answer. In the final step now, we will have
We will now have to now check the number where this substance group what appeared. So we count from here 1, 2, 3, 4. The substance group appear in number what? 3. If we count like this 1, 2, 3, 4. The substance group appeared in number what? 2. And remember what I said. I said you should be giving the substance group the lowest possible number. Do you get that now? Lowest possible number. But have it in mind that as I'm writing this 3 here, this 3 is showing for this 2. That means it's 3, 3. This one is not going to what? 2, 2. Let's now assume again. Let's assume again that when you are solving a question, you saw this thing in here. You saw it here. Assume, we are still speaking, assuming. So let's assume that here is also it here. That means this one is supposed to be 1. Now supposed to be 1, comma 2. And when you count them from here, it's now 1, 2, 3, and what? 4. It's now be 3 and 4. Hope you remember what I was doing. So if you say, now let's now give this, remember it's lowest possible number. Let's now check the lowest possible number. 1 plus 6 is going to give you what? 3. 3 plus 4 is going to give you what? 7. Which one is the lower? Between 3 and 7. It's going to be what? 3. So choose this one. Lowest possible number. If you don't get this particular thing, just forward it back a bit, then you can continue. You're going to get it. Just play it again so you can going to get it. But let's continue. For this particular tool, which one do you think you're going to choose? 2 plus 2 is going to give us 4. 3 plus 3 is going to give us what? 6. Which one are we going to choose? We are going to choose this. Now, if we choose this, these two things are not the same attachment. We have another issue again. Now, since these two things is not an attachment, between chlorine and methyl, which one are we going to write first? Oh, this is my problem. Let's go back to our primary school. Our primary school teacher will settle this. Remember that I didn't teach us about alphabetical order. In alphabetical order, they always say that the ones in alphabetical order between C and M, which one comes first? The C itself is come first. So we just choose it. We now start again. It will now be 2 chloro, 2 methyl. Remember, you are putting this one first. Butane. That is the answer. 2 chloro, 2 methyl what? Butane. So let's check our answer here from the option going up. I already know you are going to see the answer. So the answer is what? D. See how easy it is. Now let's go to number 3 question. This number 3 question, I'm not going to talk about it much. So, but the answer there is vanadium 5 watt oxide, which is what? D. So let's talk about the number 4. So hope if you are enjoying this particular video, or if there is a video you want us to talk about more, so we can be able to talk about it, as in just leave the comment in the description and let's go. So the number 4 says in the preparation of salt, the method employed depends on what they say: A, composition; B, dissociation ability; C, stability to heat; D, precipitating ability. Now, in preparation of salt, there are 2 things you have to consider: the solubility and the stability to heat. And if we look at the answer here, we have stability to heat, which is going to be the answer. Now, again, number 5. Okay, so in this number 5, I have to write it out because I want to analyze it very, very well. The way we have been analyzing the other questions we have been solving. So, reaching to this particular question, we have which of the following, in case I'm not seeing the board, the question will be on the screen. So, don't bother, the question will be on the screen. So, which of the following numbers form acidic oxides with oxygen, except we have A, phosphorus; B, sulfur; C, carbon; D, chlorine. Oh, this is tough. Don't worry, this is not tough. This is why you're in LFS. You always find out your X. X is your problem, so you always find it. Now, let's move over to this particular question. Now, if you look at phosphorus now, most oxides of phosphorus, like the phosphorus 3 and phosphorus 5, the 5 acid, All of them are acid. They are acidic in nature. Then we have sulfur. We have sulfur 3 and sulfur 6. They also what acidic in what nature. We also have carbon. Now, if we reach carbon now, we have carbon 2 and carbon 4. If we reach carbon 2 and carbon 4, only carbon 4 is acidic, while carbon 2 is neutral. It's not acidic. Then if we reach to this chlorine now, we have chlorine oxide, we have chlorine perchlorates, we have chlorine peroxide, and also have chlorine tetroxide. All of them are what acidic in nature. Now, if you notice that all these things we listed, they are what acidic. What is Jamb looking? What are they looking at? All these things are acidic. So which question are we going to pick? But look at this particular question. They say oxides. He didn't say oxide. And they say oxide. That means all this answer is what's correct. But they say oxides. In all these things, I mentioned 2 oxides of phosphorus. I mentioned 2 oxides of sulfur. I only mentioned 1 oxide of carbon. And I mentioned close to 4 oxides of what? Chlorine. Which one do you think is going to be answered? Because they mentioned plural. They didn't use what? Oxide. So our answer is going to be what? Carbon. So now, move over to the next question. I know you already know why we pick this carbon. Because carbon form acidic oxide from carbon 4, not acidic oxides. So pay attention to that. Jamb is always technical, so you have to pay attention. That's why majorly we always try to, as you are reading, you try to pay attention, and that's why LFS is here. And we'll have a motto: find your X, find your success. And this is where you're going to find your X, this is where you're going to find your success. So let's go over to the last question of the day. I know you're really enjoying this. So let's go to number, I think we're in number 6 now. So in number 6 question, in number 6 question we have, how many neutrons are present in atom with mass number and atomic number 37 and 17 respectively? So the question is what? So let's pay attention to the atomic number 37 and okay, there's a mass number of 37. We have atomic number 17. You now ask you what is what? How many neutrons is inside? Have it in mind that what make up what we call mass number is 2 things: proton and what? Neutron. Once you add proton and neutron together, you get what we call what? A mass number. And what make up atomic number is just the protons. Do you get that now? That means for you to get this mass number, you have to add the atomic number and the neutron for you to get the mass number. So for this particular question, we're already given 37. You understand now? So if we now want to now get the number of neutrons that was added to this, so we now form the mass number. What am I going to do? Now say that 37 minus what? Atomic number. What is atomic number? 17. And when 37 minus 17, we are going to now have 20. So let's look at our option. We have option A, 18, option B, 20, option C, 37, and option D, 17. So the option B is what? 20. So stay tuned as we analyze more questions. Drop a topic or a question you are having difficulty on. Drop it in the description so that we can also be able to record video on it. We are running a free video promo for this week. Just try to drop down your question you are having issue. Make sure you share this particular question to your fellow Jambites, your fellow scholars, so you can be helping someone today as you are what? As you are preparing for Jamb. Remember, find your X, find your success. You are here to find out your X, and you are here to also find your own success. Thank you very much, and I'm very blessed.